Okay, let's go through this question today. Quite a difficult question. So we have this setup, right? Coil X is connected to a battery. Then of course a rheostat here. Then coil Y is connected to a galvanometer. So they say that when the switch is actually closed, the pointer in the galvanometer deflect momentarily towards the right hand side. So when the switch is closed, which of the following action will actually cause a momentary deflection of the pointer towards the left? Okay, so first let's look at the let's look at the setup first. So I close the switch. Apparently, right, the current will flow in such a manner. So to deduce what is the pulse at X, I just need to use your right grip rule. So you use a right grip rule, apparently your thumb is pointing towards the left hand side, meaning this is the north pole, this is the south pole. Yeah, so this is actually correct. Okay, but for coil Y, right, in order to oppose the change, because apparently there'll be a magnetic field in this direction. So for example, I draw this direction, right? So it's actually pointing from south to north. Why is it south to north? Because you must treat the solenoid as the inside of the magnet. Meaning, for example, right, okay, this is north pole, this is south pole. Then you just draw, okay, this is outside the magnet, so this is north to south. But if you're talking about inside the magnet, you must point from south to north. So this is the correct direction of the B field. Okay, for coil Y, since it experienced a sudden increase in the B field in the leftward direction, right, it will want to induce its own B field to oppose the change, right? So for example, of course, coil Y will want to induce a B field towards the right hand side. Means that this must be north pole, this must be south pole. So you can see south and south is like that. So of course, to induce a south and north in this orientation, you must induce your own current. Means that for example, use your right grip rule. Your thumb is pointing towards this direction, right? Your right hand, your four fingers are actually gripping in this direction. So maybe I just erase this first. Okay, so your right hand is moving in this direction. So if you trace the current together, right? So for example, you trace the current is actually moving in this manner. So that's why your galvanometer actually point towards the right hand side, which is consistent. Okay, so now we want to deduce what action would actually cause the deflection to point towards the left hand side. Okay, in order to point towards the left hand side, definitely the poles must switch. Meaning, for example, okay, so maybe I just draw here. So this is your coil Y. Coil Y. So for the thing to deflect towards the left hand side, you must make sure that this current is flowing in this orientation. So of course I draw the wires. So this part is the frontal part. So this part will be the current. So this is a frontal part. So you use your right grip rule. Apparently you grip in this manner, right? Your four fingers are gripping in the direction of this current. Means that your thumb is pointing towards the left hand side. So this is your north pole and south pole. So for the galvanometer to actually deflect to the left hand side, right, this must be north pole, this must be south pole. Okay, so let's take a look at all the options. So they say, okay, first move coil Y quickly towards coil X. So what effect does this actually cause on coil Y, right? Okay, maybe I use a very simple analogy or simple example. Okay, so this is coil X. Meaning, okay, so coil X we know, left hand side is north pole, right hand side is south pole, right? Then, okay, this is your coil Y. So this is coil Y. So you move your coil Y towards the X, right? So of course, you want to oppose even more. Your coil Y must oppose even more, right? So means that this is still not south. Sorry, this is still south. This is still north. Okay, you can think of it as the magnet. For example, X is a magnet. North and south pole, right? So this X. So this is the coil Y. Maybe I just draw in terms of the coil. So this is your coil Y. So this is coil Y. So when X is moving towards the coil Y, this part must be south pole, because you want to oppose, you want to prevent this person from coming in, right? So it's south pole here and north pole here. So what you're actually doing, you are still causing the galvanometer to actually point towards the right hand side. So it's not pointing to the left hand side, right? Okay, so number one option is out already. Okay, what about number two? Number two, they say move the slider of the rheostat quickly towards NP, meaning the slider is like that. So you can see it. So now the current need to flow more in the rheostat, right? Meaning that the current will decrease. Because your resistance, when you move your slider towards P, your resistance actually increase. Because you look at how the current flow, right? So the current going to flow like that, then you're going to flow through the whole of this rectangle. So it means that the current must decrease. So when the current decrease, the magnetic field will decrease as well, because magnetic field and current is like directly proportional. So if your current decrease, means that the B field decrease as well. Okay, so what happens to this Y, X and Y lah? Okay, so when your current decrease, means that your B field decrease, meaning that coil Y actually experience a decreasing magnetic field in this direction. So so maybe I just draw this. Okay, so what the coil Y would do, right? It will actually want to increase the magnetic field in the left foot direction. Meaning that this part must be north pole, this part must be south pole. So this will actually cause the current, right, to flow in this orientation. So you can see, right, it's flowing in this orientation. As long as the coil Y, right, the left hand side of coil Y is north pole, the right hand side of coil Y is south pole, right, the current will flow in this manner. Meaning that your galvanometer will point towards the left hand side. No. Okay, so that's why number 2 is the correct one. Okay, of course, let's take a look at number 3. Move the slider of the rheostat quickly towards NQ. Okay, so now is the opposite effect of number 2, right? So when you move slider towards NQ, you're actually decreasing resistance. Why is that so? Because you think about this, right? The current flow, then I close the switch, flow like that. Okay, flow to point Q, right? Instead of flowing to the rectangle part, you straight away go to the slider and go back home. So in this manner, right, you actually increase your current. You are decreasing your resistance. Okay, maybe I draw here. So this is your coil X. So you are increasing. So for example, right, current increase means B field increase. So meaning the coil X, right, will increase in your B field in this direction. So now we have another coil. So the coil Y is like that. So coil Y will experience an increasing B field towards the left hand side. So what happened is that, okay, now the coil Y decided to oppose the change, because I'm experiencing an increasing B field towards the left hand side, right? Means that now my coil want to induce its own B field in this direction. You want to oppose the change, no? So of course it's pointing towards the right hand side, right? The B field, the green color arrow. So this part will be north pole, this part will be south pole. So when this part is north pole, this part is south pole, right? Of course the effect is the same as number 1. So for example, right, so north pole, south pole, so the galvanometer will actually flow in this manner. Will actually point towards the right hand side. So that's why for this question, right, the answer will be 2 only.